Audio check.
Yep, I can hear you. Good morning, everybody.
Hi, everyone. Thanks for joining the meeting today.
Good morning, Bobby.
Morning. Let's give people maybe a couple more minutes to join in. Right. Okay, I think maybe we should start it earlier. Karen, you said you have some questions you would like to bring up on the session.
Oh, yeah. So I'm working on the metrics chapter, and of course, that's kind of a summary of everything. And I realized I had some questions, and I apologize that we may have discussed this and I've just not remembered.
No, I think it's great to bring it up.
I think one of the challenges is that we're really talking about explicitly, and I read the very nice contributions there already are, especially the opening chapter, and it kind of talks about different phases, right? LPO, CPO, and photonic fabric were called out as it sounded to me like three phases. So then if we're identifying targets, do we have different targets for those three phases? Or do we say, the ultimate goal is the target, and then these are just, you get as far as you get on each path? And then associated that with is time frame. If we're going to identify targets, what time frame are we talking about?
That's yeah. I don't recall we discuss anything like that. Does anyone has any suggestions about this? Yeah, because I think the matrix is is it something that we should maybe we should have a discussion with Raymond? I had a conversation with not Raymond, Ryan. I had a conversation with him on Tuesday about the chapter 4, and he's working on three different tables. So so he's gonna organizing the session using the table with I think um, the different speed and different different form factor, then how to and the third table would be, you know, how these things fitted in together. So I think it is very close to what you just mentioned about um, the metrics and the target. And I don't know. I'm very open to anyone's thoughts about this.
Well, I have a lot of thoughts, but I was late, so I'll hold back.
Oh, Bijan, you have some ideas, then welcome to share.
Yeah, actually, I've been scribbling on on a copy of the document, just kind of trying to get my thoughts together. I'll make some updates to the document first, and maybe we can talk about it next week.
Oh, okay. That's great. Thanks for doing that.
Which document are you referring to?
Sorry, I'm slow on the mute button. The white paper.
So is there a particular chapters or the
Yeah, I actually have kind of sketched out some what I think are some missing parts to it. So I just yeah, I just need to put that, kind of put it back in the document. I'll let you guys take a look at it, and we can kind of maybe start talking about it next week.
okay. Yeah, I think I don't know if that would kind of the update would be crossing a different chapters, or would that be just focusing on the particular sessions?
Yeah, I wanted to kind of round it out, and I wanted to kind of make it more, less high level, I guess, and more actionable in some way. So I'm trying to put together some like very more market, specifics, not specific to any one company or whatever, but just more about the whole state of the art of everything, and just kind of tie it all together. I thought there were some missing context in there, and so it wasn't very. It just kind of jumped around in my book. So I was just trying to help, kind of level it out a little bit.
Okay, great.
And also I'm focusing on requirements. Let me just put it that way. Maybe that'll make it easier. What I just said was maybe difficult to follow if you haven't looked at it, but yeah, so I'm adding some requirements in there. Just, then we can all take a look and maybe throw some darts or whatever, but I just want to draw a line in the sand and say, hey, here's what, here's something that we could look at and work on.
So Bijan, in terms of requirements, we have that, we have that spreadsheet that I think Ron put together. Is that the kind of thing you're looking at, or are you looking for something different?
I'm just kind of adding a little bit beyond that, and kind of, I'd need to go back and look at, I haven't looked at that spreadsheet in a while. I need to go back and check it, I guess. But yeah, I was just trying to add in more requirements kind of beyond that so that we can kind of have a direction, if you will.
And then back to Karen's question at the beginning. So Karen, your question was about how to incorporate like LPO versus half retimed and things like that. Is that sort of the question? How to do the requirements for that?
It's not so much LPO as half rate and versus half rate timed, but more that the scope seems to be the application, and the opening mentions, and probably the successive chapters also mention different approaches that also seem to possibly span different time to market. So that, what I was finding and what I'm actually winding up writing in the metrics section is that, in our outline, we have this long list of maybe 10 metrics. And what I was realizing is that there's some high level ones that are basically system requirements, right? Or tied to system requirements, power, basically power and performance. And so, if you said at a high level, and I think, probably your work, Jeff, has come to the same conclusion, is that, at a system level, reach, cost, power are kind of things that impact the entire system. And then in this particular application, latency as well. And then things like density and error rate and reliability and diagnostics are capabilities that optics needs to be at least competitive in, so that those trade-offs between, say, power and reach don't, or cost and reach don't no longer cause optics to be uncompetitive in meeting the overall system metrics that you want, that the trade-offs are worth it. So, but then I was finding that, well, but then if you add time to market into that sort of overarching architecture list of cost, power, latency, and you add time to market, and the end goal is to optimize performance, let's say, you come to different answers depending on, for example, time to market, and that's the issue, is we can't have a tidy list of targets when there's trade-offs between them, and you wind up with different trade-offs. And those, let's say, the three very different approaches of LPO or half retimed but pluggables CPO and then these, what I think it was called photonic fabrics, represent probably very different trade-offs of those metrics, particularly where time to market is different. And so I don't see us coming up, unless we resolve that, I don't see how we can come up with a single target value for each metric. Unless we say, oh, in the ultimate case, we want this, or some such, right? But I just don't see how we can come up with a single number.
Yeah, I think you're exactly right. So, I mean, I think the way to look at it from my point of view is what's the most important thing they care about? Well, one of the two most important things are cost and reliability. And then as they architect the system, they'll choose the lowest power for the architecture they're going to choose. So that's how I look at it. Does that make sense?
So yeah, I think I guess subtly differently, I look at it as people have architected systems now. They are not using optics. Why not? What are the two things that need to change in order for them to adopt optics? And yeah, I would agree with you. Cost and reliability seem to be the biggest barriers.
I mean, I think those are the big two. But I also have, over time, like when Mike started writing when he had that meeting at the global summit, and that everyone came together, I had a lot of conversations that were very theoretical at that point. Like, people were looking at optics as something that was in the horizon. And so they had these, the problems like Andy B would bring out was the fit rates and things like this. But I think those, the conception of those issues still exist. The perception of those issues still exist in everyone's minds. But I think the other practical thing that's really bubbled up in my experience in talking with people is that the efficiency is now being held up as a problem, and so and my view on that is,
Bijan, what do you mean by the word efficiency?
well, yeah, so there's different kind of domains to that, dimensions to that. Like one dimension to that is just simple power efficiency, I guess the easiest one to talk about. I heard someone the other day, I was talking to someone the other day and I said, hey, if you look at the trends and all this and that, everything looks good. And they're like, look, I'm not going to spend this much power to do that when copper is fine, for example. And I've also heard like, all of these hops cost latency, and I don't see this isn't a good trade-off for me. So I think there's some contextualization that needs to take place so that people can understand it kind of like maybe a little bit what Karen is mentioning at a systems level, like how this fits into the big picture, because it's not the replacement for everything, and it's not and it's not a bad idea. It's somewhere in the middle. So hopefully that
Yeah, I think that makes sense, Bijan. I mean, the simple answer is if you can use copper, use copper. If you need to build a bigger system and it requires a hop through a switch, use a switch. It's sort of like what your system goals are, and then there's a whole range of options, and if you decide you don't want to do co-packaging because you think it's too risky, then use pluggable modules. If the electrical channel is short, then use LPO or half retimed. If it's longer, use fully retimed. You know what I mean? It's just like
exactly. Yeah.
There's just a whole range of things. I don't know, like Karen said, I mean, I don't know that we can imagine all of the different ways people would want to architect the system. But if we focus at the optics level, we don't have to worry about hops. And, as far as retimed or half retimed or full retimed, it all depends on the electrical channel, you're right, that's feeding it. And, so on. So if they have to trade off power versus robustness of the link versus the electrical channel loss. I mean, these are things we can highlight, but I don't know, I think if we just focus on the electrical specs for the optical device itself, requirements for the optical device itself, it can be used in many different ways.
So this is kind of what I'm trying to, that's what I'm trying to capture in the writing in that white paper.
Yeah.
And Mike, to your question, did that, does that square up with what you were thinking, or is there some other thing that you had in mind?
No, I think that very much squares up, and basically what you're calling efficiency is what I'm calling trade-offs that make the overall system performance improve or not, right? I mean, you might use optics and increase reach, but it kills your power budget, as you say, and then that would be bad. Or in order to achieve the error rate, you use some kind of very complicated error correction that kills your latency, right? And that clearly would not be a good trade-off. So I think it does. I think you're sort of confirming. I think what you're calling efficiency is sort of confirming, my list of basically the power and the latency, and then I guess you're saying that, and I think Jeff is saying reliability is kind of another thing that I think Jeff's comment was a slightly different one, which is what were the issues with what are the barriers with optics that were it's a prioritization list in terms of what's most relevant for optics, as opposed to there's two views, right? One is, of course, the priority in terms of overall system impact, and then there's a priority in terms of what are the hot buttons relevant to optics, right? And I think those are two different prioritizations, and so maybe that's two different tables of metrics, I'm thinking. So which would be, I think, good structurally for us to have two shorter tables than one huge table. So I think that's what I'm hearing. And I guess I hear, Bijan, that you're going to be adding some things to the outline that relate to the more the system view and practical
Yes.
things. Okay. So I guess, and I'll take the feedback that I'll keep chugging away, but I'll just warn you, I don't have hard values to put into these tables. So what I'm thinking is maybe I'll draft the chapter. Structurally, we can discuss it then when I've got a draft to review, and then we can talk about the values. How does that sound, Bobby?
Yeah, it sounds great. I don't have a very strong opinions on this. My mind was kind of drifted around to thinking about what it would be the, from thinking about the first principle, and what would be the limitation for people to put more dense computing and use copper all the way, right? I think recently NVIDIA's it's just increasing their scaled up counts into a rack even more. Google's was talking about 1 megawatts rack in, I think, in the earlier OCP regional. So I was kind of thinking that, what would be the point that you definitely reach the wall, or reach to something that that is definitely not cost efficient to put such a high power into a very small volume. Is there anyone have a rough idea for that?
Well, it seems like the upper limit would be thermal, right? Because at some point the material can't support any higher thermal density.
Yeah,
And
but
so-
people are changing, from air cooling to liquid coolings, and
Oh,
maybe there will be
oh
more
yeah,
cooling
I'm
technology.
looking way up the curve. So you asked a question, you said something about first principles, so I just immediately went to, okay, what's the maximum compute density possible, right? What's the limit? And
Right.
the limit would have to be, you know, maybe the melting point of the materials in the semiconductors, and then you kind of work backwards from there.
Right.
I think ultimately you could probably characterize a swag at what that maximum number of, transistor density is based on the types of transistors and the materials that are being used. And then that you can kind of derive the maximum compute capability from that density of transistors. And of course, you don't, you're assuming that you can cool it all with something, and at that point you might be beyond even simple liquids. You might be looking at cryogenics. But anyway, that's not the problem you're trying to answer. The question you're trying to answer is what's the upper bound on compute? And then the second question to me would be, how do you get there? How can you even enable that? What would enable that? And don't know this, but just, intuitively, I don't think copper traces can do that. But, that has to be worked out. You probably weren't expecting that as a answer, but
No,
that's what came to my
I
mind when you said that.
no, I think that I'm following your thoughts and start thinking about, like, um, just assuming everything becomes like a capacitor. If we build a capacitor with sheet of a capacitor, and then what will be that volume for that, and the thickness of a wafers, and put all the things together, by not assuming any power supply limitations or other things. And what will be that density about? Is that gonna maybe higher than the energy storage for explosion or something? Because I think the explosion for the energy, when you try to flow through so many energy in a fixed volume, that kind of reach to something more like a explosion condition. And so that's I think you gave me the very good ways for thinking through the things. Then I think the limitation would be, how can we move all heats by that, and is that going to be a balance for the cost of the optics be less than that?
Yeah, there's probably, if you keep going down this path, I can imagine being able to draw a graph with the curve of, increasing energy density, thermal density maybe, and then
Mhm.
Interconnect density. And there's probably some, region in which copper makes sense. And then there's a region in which optics makes sense. And then there's a beyond that region, which we don't have an answer for right now.
Yeah.
But our job, well, our goal, I guess, not our job, but our goal is to kind of exploit that area where it only makes sense to use optics, and be able to define that to people so they can understand it.
Right. Right. Yeah, totally. Okay, so I think we're about time to have many good conversations today's, and if so I'm looking forward for next week with more updates about the white papers, and we can chat more about it.
Yeah, I have to go to a different meeting, but thanks everyone. I'll try to be a regular participant and keep stirring the pot, because I believe there's a lot of value here at OCP to do something which is not happening in other organizations. It's probably, makes sense to have something here. But anyway, we'll keep stirring the pot and see what we come up with.
Great. Yeah. Thanks, Bijan.
Thanks everyone.
Thank you, everyone. We'll see you next week.